Hi, my name is Yeoh Kar Hau and my machine number is A20A2089. We are from L1T1 Group 10. My teammates will introduce themselves. Now I will start my presentation. First of all, business statistics tests the data analysis tools from elementary statistics to manage the problems. The main objective for this study is to analyze the data of central tendency, variation, and position with using numerical descriptive measure. Besides, we are also using the SPSS software to interpret the data by using t-test analysis, ANOVA analysis, correlation analysis, confidence interval, and regression equation. The topic that we choose is the prices of fishes captured at several places. We choose price, wedge, and hedge as our study fields. According to the instruction, we know that the dependent variable is price and the independent variables are wedge and hedge. Next is data descriptive. We use the SPSS software to choose 60 observations from 150 cases. The data shows that 7 species fishes, 10 places, and other variables has been chosen. Then we describe the data with using 3 types of table. First is frequency distribution for price. Our data is group data because it produced whenever observations are sorted into classes of more than one value. The first step is to calculate the number of classes. We use the formula which is 2 square of k greater than n. N is our sample which is 60. So we get the 2 square of 6 is equal to 64 is greater than 60. So the number of classes is 6. Then we must determine the class width with using the formula maximum entry minus minimum entry divided by number of class. So the class width for price is 166. So we can make the table as on the slide. The frequency variable of which is using the same formula, just the class width is different, which is 275. Next, we calculate the relative frequency by using the same table. The formula is class frequency is divided by the sample size and the answer of the sum relative frequency is equal to 1. Then the last one is cumulative relative frequency. The formula is sum of the frequency for the class and all previous classes, and the last class is equal to the sample size which is 60. Next part is numerical descriptive measure. The first measure is central tendency, which is mean, median, and mode. Mean is the average of the sample class. This is the formula. Therefore, the mean of wedge is 394.98 and the mean of price is 351.73. Next is median, the middle of data entry. So we fill up the number into formula, then we get the median of wedge is 241.1143 and the median of the price is 191.5124. Last is mode, the value that appears most frequently in a dataset. We also fill out the number into the formula, so we get the mode of wedge is 136.5778 and the mode of price is 112.2905. That's all my part. Thank you.
Hi madam, my name is Kang and my number metric is A20A1349. Today I will present about part 3.2 and 3.3, which is measure of position and direction. For 3.2, formula for first quadrant is Q1 equal to LQ1 plus N divided 4 minus F divided FQ1 times C. So the first quadrant for red is 123.2571 and for the price is 102.68. Formula for the third quadrant is Q3 equal to LQ3 plus 3N divided 4 minus F divided FQ3 times C. So the third quadrant for red is 673.2571 and for the price is 625.58. Thus, the formula of interquartile range is third quadrant minus first quadrant. So the interquartile range of red is 550 and for the price is 552.9. Furthermore, 3.3 measure of variation. This is the complete table of red and this is the table for the price. Formula for range is maximum data entry minus minimum data entry. So the range of red is 1644.04 and for the price is 990.374. However, sample variance formula is S squared equal to 1 dyn minus 1 times bracket sum of Fs squared minus sum of Fs squared divide n close bracket. So variance of red is 11285412.6.5, and for the price is at 9633.7177. Yes, standard deviation formula is s squared equal to square root s. So standard deviation for red and price is 10623.2823 and 299.3889. On the other hand, the share of distribution for red and price are same, which is skewed to the right because mean greater than median greater than mode. That's all for me. Thank you.
Hi, my name is Muhammad Zufayri. My matrix number is A20A2325. So, I'm going to present graphical representation. We go first for Ogif graph. Based on the graph above, there's a rapid growth at the starting point of the graph. This is because the low weight of fish is easy to capture compared to fish with higher weight. Generally, the quantity of the fish high weight is not too much. As a result, the pattern at the end of the graph is low. Next, we go to histogram graph, which is the name of graph is prices of the fish capture. So based on the graph above, the prices between 3.58 until 168.58 have the highest frequency compared to other classes. This is because almost all fish have their standard price, which are between 3.58 until 168.58. However, not all places follow the price standard for fish due to limited species in their place. This leads to the consequences where people have high demand in some species, resulting in increasing prices. The lowest frequency in the graph is 4. It is because people in some places are not familiar with that species that the price are not too high. Due to the limit of this species, the price is not too low. Numeral descriptive measure for the price. The mean by calculating manually is 351.73. However, the mean by calculating SPSS is 341.0.0425. The difference between both data is 10.6875. For calculation of median, calculation manually is 191.5124, but calculation of SPSS is 227.4550. There are 35.9426 differences between them. What is calculated by manually is 112.2905. However, calculation of SPSS is 3.58. The difference between them is 108.7105. So we can see the histogram graph as comparison with histogram graph that calculate by manually. Both are show the decreased trend. And for Ogif graph as a comparison with graph that calculated by manually, both are slightly increased. So that's all for me, and thank you.
Assalamualaikum Dr. Ain. My name is Sofea Adreena, matric number A20A2002. Today I want to present for 5.2 hypothesis testing. So for ANOVA test, okay, as we can see for step 4, okay, is a decision rule. We reject hash null if f greater than f alpha. We can see at step 3. F is 56.950. So step 5 for decision, we reject hash null since f greater than f alpha, which is 56.950 greater than 2.386. So therefore, there is a significance difference among the treatments. Okay, for t-test, okay, at step 4, decision rule, reject hash null if t modulus greater than t alpha over 2 df. So at critical region, we got from table 2.001. So for step 5 for decision, okay, we reject hash null because 9.234 and 13.2 361 greater than 2.001, as we can see at the table at the test. Therefore, we can conclude that mean is not equal to weight group. Okay, for test of normality after a standardized, the Kolmogorov-Smirnov test of normality on the residuals give a p-value of less than 0.47, which is less than 0.05, significant 11. Thus, the assumption of normality of the terms is doesn't met. The next is 5.3 correlation analysis. There is scatter plot. There is 3 graph. Graph 1 is price against weight. The higher the level of weight, the higher the value of price of fish. For graph 2, price against height, the longer the fish, the higher the value of the price. And for graph 3, weight against height, seen that the longer the fish, the higher the level of weight. For table of correlation, the R value between price and height both are greater than 0.3. Thus, price is associated with both weight and height. The R value between weight and height is 0.779, which is less than 0.85. Perhaps there is no problem of multicollinearity. Thank you.
Hi, my name is Nora. I'm Binti Kadir, matrix number A20A1646. Confidence interval. Confidence interval is a range of value within which the population parameter is supposed to exist. The 95 confidence intervals can be related confidence level based on the result of SPSS above. Both of the lower boundaries and the upper boundaries calculated by SPSS are 259.4703 and 422.5747 respectively. Also, it represented the standard error for this that we are 79% confident that the population parameter is between 259.4703 and 422.5747. For prediction modeling, the most commonly used type of linear regression analysis is multiple linear regression. For model summary, we got the R square is 0.929, which means 92.9% of the variation in price can be explained by weight and height. The Durbin-Watson statistic of 1.578 is a little bit far from 2, which is different 0.422. The Durbin-Watson statistic is used to test for the presence of serial correlation among the residuals. In conclusion, the sample data that we choose, which is the price, weight, and height, is the fish's capture, and we had analyzed the price as the dependent variable, and the weight and height is the independent variable.